Okay, so in this question here, as I told you in the previous lesson, when you're answering these questions, you must always check for the following: the center, diameter. Okay, those two are very important. The radius, right, and also your chords, right. Later we are going to add cycle parts, and we'll also add tangents. But at this stage, you need to check if those four are there. So if you read the question, we have a diameter. The fact that there is a diameter here, it means somehow you need to use theorem 3. Angle in a semicircle. Okay? We have got a center, which means you might need to use theorem 2, you might need to use theorem 4. Okay? Also, because of that center there, it means that you have to use theorem 3. Right? Your radius is also there on the diagram. OE is a radius, ON is a radius, and OM is also a radius. So we have got 3 radii here. Then the chords, we have got NE, we have got ME, we have got MS. Okay, which means we might need to use theorem 4. You're following that? Okay, so when you're answering the question, you must have a strategy of how you approach the question. There has to be a strategy. Okay, if you don't have any strategy of tackling the question, then you won't be able to do it. You'll be stuck forever. Right, so let's look at the first angle. We need to find the size of this angle. Now, I also want you to be aware that your knowledge of triangles is very important. I'm sure you can see that angle O2 is an exterior angle of triangle MEO. Okay, it's an exterior angle. So M2 is 55. So this angle here is 55 degrees. Okay. Also, from theorem 3, that angle there is going to be 90 degrees. Okay, which means I can easily find O2. Okay, because this whole angle E1 plus E2 is going to be equal to M2, because MO is the radius and OE is the radius.
So why would you say angle is 90 degrees?
Was it's an angle subtended by the diameter, theorem 3. So I'm trying to get O2 first. So 7.1, first thing that I will write is to say OM is equal to OE, and these two are radii. Okay? Now, angle M2, they want to find O2, so I'll say angle M2, okay? Angle O2, let me write this way first. I'll say angle M2 is equal to angle MEO. Angle MEO. You agree with me then? Huh? You're supposed to be looking here. M2 is equal to MEO. Alright? Why? So it means both are going to be equal to 55 degrees. The reason angles opposite equal sides, not isosceles triangle, as I said last time.
So would you have to use the reason of isosceles triangle would be wrong?
From now on, it won't be accepted. I know that in the lower grades you used to give that as a reason. Okay? So OM is equal to OE. They are both radii of the circle. And there are also two sides of triangle MOE. Once I got this, it becomes interesting. Then I can say O2 is equal to M2 plus MEO. Why? Because of exterior angle of a triangle. Here, exterior angle of a triangle. You were taught that in grade 8. So this becomes 55 degrees plus 55 degrees, and you get 110 degrees. So that's the size of O2.
I just said that I said that O2 is equal to 2 times Q2 because I was doing 0.
Yes. Okay.
It's right, sir.
Yes, it's correct. If you saw it the way that he saw it, this angle here is subtended by chord EN. So if and this angle here is on the circumference is also subtended by chord EN. Therefore, angle at the center is 2 times angle at the circumference. So that's also correct as well. Okay? So that's theorem 2. Okay, now this is very important for you. When you're answering geometry questions, right, do it based on what you first saw. You see the diagram. Okay, I didn't see what he saw, and probably he didn't see what I saw. But both of us will get to the same one, same result. So you answered based on what you first see and what comes into your head at that time. All right. Okay, so we could write it as saying, let me write this solution. So another way would be to say angle O2 is equal to 2 times M2. Then write the reason. Angle at center is equal to M is equal to 2 times angle at circumference. Right? Therefore, your O2 is going to be 2 times 55 degrees. And you get 110 degrees. Can you stop that? I'm recording. Okay. All right. Any questions before I move on? Right. Once you find O2, this angle here, the next angle that we need to find is angle S. Okay? Yes?
Sorry. So let's say in the exam we got this question, and now some people will use that.
You still get the same amount of marks. You get the same amount of marks. But in actual fact, in a memo, they provide both solutions. Right? So we need to find the size of this angle. This is the way that I would do it. If I want to find the size of angle S, I'm going to find the size of angle N first. Because angle N and angle S are equal because they are angles in the same segment. They are both subtended by chord ME. So first thing, I'm going to calculate the size of angle N. Okay? To do that, okay, let's carry on. Okay, let's carry on. I don't want to hear the word you are doing below because that's what I saw. And it's correct. If you saw a shorter way, that's how you saw it. Remember, I'm not doing the question from a memo. Don't forget that. I'm not doing the question from a memo. I'm doing it from my head. Okay? So, and I didn't see the answer before this lesson that, okay, the answer for this question is like this one. I'm doing it from my head. So I'll answer it based on what I want. I'm seeing. Okay, if you have got a suggestion about another way, I welcome it as long as it is mathematically correct. There's no problem. Right? So, the way that I'm going to do it is to find the size of that. Okay? So, I'm going to say angle MEN is equal to 90 degrees. And that's angle in a semicircle. Okay? Just allow me to do it quickly. Right? Then, in triangle MEN, okay, M2 plus MEN plus angle N will give me 180 degrees. That's sum of angles in a triangle. Okay, so my angle N is going to be equal to 180 degrees minus 90 plus 55 degrees. And I'll get 35 degrees. Okay, then I'm going to take on from here, I'm going to take on to the top. Angle S is equal to angle N they are both equal to 35 degrees because that's angles in the same segment. Okay.